In this lesson, we'll look at the integrals of exponential functions and specifically just e to the x. We won't do other bases yet. And so we know that e to the x is its own derivative, and that means that it's also its own antiderivative. Since there's not much to do here, every more challenging integral just will require substitution. So here we have the inside function is 2x, the outside is e, so then we look at substitution. U is the inside. We solve for the differential of x. We won't need this because there are no limits, and we won't need this because everything's going to cancel. So dx is du over 2. And we can just take the 1/2 in front. The antiderivative of e to the u is e to the u plus c. And then substitute back. Pause the video and try that one. Substitute for 3x plus 1, and the differential of x is du over 3. So we'll take the 1/3 out. Antiderivative is e to the u. And then substitute for u, and that's 3x plus 1. And here we have two different inside functions, so why don't we just break it up into two integrals. We can do substitution twice. So here we have 2x is u, and dx is du over 2. Negative x is u, and dx is negative du. Now if we do an integral and we get a plus c here and we get a plus c there, they're both constants, so if I if I said this was C1 and C2, you could combine them to just be C. So it doesn't matter if you just either put two C's or one C. Then we substitute back. Here it's 2x. And here it is negative x. And we could, we were able to keep track of the u. These u's are different, so maybe to be careful, we would write this as a v. If we're doing two separate substitutions, it's fine if you leave it as a u. But to be careful, maybe make it a v, so you see that v is negative x, because what we were saying is u equals 2x and u equals negative x. Maybe if someone's picky, they'd want to see different variables. And why don't we also add this in, write a plus c1 and a c2. That's what I talked about, but now you can see it. When you do this antiderivative, you have a plus c1. This antiderivative is a plus c2, but c1 c2 is just some other constant c. So we can write the answer like this. All right, pause the video and try that one. We do have separate inside functions, so we can break it up into two integrals. And remember that the variable cannot go on the outside, but the constant factor can go on the outside. So we could say this is that. And then over here we have to substitute. X squared du is 2x dx. Du over 2x equals dx. So if I do this antiderivative, we get e to the x plus c1. For this integral, we'll have x e to the u, and dx is du over 2x. So we get to cancel the x. And we'll have 1/2 e to the u plus c2. And we know u is x squared, 3e to the x plus, and we're going to combine c1 and c2 as a c. We'll have a 1/2 e to the x squared. All right, now we have limits. It's a definite integral, so when we do substitution, we'll have to remember to evaluate u at the limits. I guess wrong notation there. I would write this down here. Du is -2 dx. du over negative 2 is dx. We also need to find u evaluated at 2. So there's u, negative 2 times x. U evaluated at 1, negative 2 times 1. And now instead of going from 1 to 2, we'll go from negative 2 to negative 4. E to the u dx is du over negative 2, negative 1/2. And the antiderivative is e to the u substitute. And we have 1 over 2 times 1 over e to the 4th plus 1 over 2 times 1 over e squared. So we can just see that, remember that the negative exponents mean reciprocals. We're going to distribute the negative 1/2. Be nice to put this as one rational expression instead of two terms. So we'll get a common denominator. We have 2e to the 4th, 2e to the 2nd. We just have to multiply by e squared. And now we'll have a negative 1 plus e squared, and then 2e to the 4th. Alright, pause the video and try this one. U evaluated at 3 is negative 3 plus 1. U evaluated at 0 is 0 plus 1. From 1 to negative 2, e to the u, dx is negative du. So we'll have a negative e to the u. The antiderivative is e to the u. Then we substitute we have negative 1 over e squared, because we have a negative exponent, plus e. To combine these, we could multiply this by e squared over e squared, and we'll have e cubed minus 1 over e squared. Alright, don't worry about the trig functions, just follow the same rules. Find the inside function and see if it works out. Pause the video and try that one. So u is going to be sine x. Du is cosine x dx. U evaluated at pi, so we put a pi here. Sine of pi is 0. U evaluated at pi over 2. Sine of pi over 2 is 1. Now we're going from 1 to 0, and it's e to the u. Cosine didn't cancel yet. Substitute for dx, du over cosine x. So the antiderivative of e to the u is e to the u from 1 to 0. E to the 0 minus e to the 1, and we get 1 minus e. All right, and we'll stop there.